In section 4.4, we're going to be working with polynomials, so we're going to be adding, subtracting, and then we'll be graphing them towards the end. So a polynomial is just an expression in this form. It's going to look pretty confusing, so bear with me. It's a sub n times x to the n plus a sub n minus 1 times x to the n minus 1. And it goes all the way down to a sub 1 times x plus a sub 0. So it looks pretty confusing. That's the technical definition. Just know that all exponents are whole numbers. So you have to remember that whole numbers are the positive counting numbers. So they're positive integers. So the exponents are positive integers. The coefficients are real numbers. And all of the terms are separated by addition. Okay, so that's all a polynomial is, nothing too crazy. We call a polynomial degree n, and the n is the largest exponent. So if the largest exponent was 4, we would say it's a degree 4 polynomial. The a sub n, so this term right out here, on the variable with the largest exponent, that's called the leading coefficient. The a sub 0 all the way here at the end, with no variable, that's the constant term. And we say that polynomials are in standard form when it's written in terms of with descending order in terms of the exponents. So it starts with the largest exponent and it gets smaller as you go. So for some examples of polynomials here, something like 5x to the 7th minus 3x to the 4th plus 2x squared minus 1. That's a polynomial. All the coefficients are real numbers, and all of the exponents are positive whole numbers. And we would say that this is a degree 7 polynomial because that's the largest exponent. Okay, something else might be like radical 2 x to the 4th minus 2x plus 7. Polynomial, all real number coefficients, positive whole number exponents. And then we would say this is a degree 4 polynomial. So notice that I'm writing all of these in standard form. And then something as simple as x to the 47th. So that's also a polynomial. It's only one term, but it's still a polynomial. And this would be a degree 47 polynomial, which is pretty large. Okay, so those are all polynomials. Some examples that are not polynomials, we could have something like 2 times the square root of x minus 4x squared plus 5. This is not a polynomial because we can rewrite that square root as 2x to the 1/2 minus 4x squared plus 5. So the part that makes it not a polynomial is the 1/2 exponent. It's not a positive whole number. Something like 3 over x squared plus 2x plus 10. We could rewrite that first term as 3x to the negative 2 by putting it in the numerator. And since that exponent is negative, that makes this whole expression not a polynomial. And lastly, something like 4x cubed minus 3x squared divided by 2x squared plus 4x. That is also not a polynomial because we are dividing by variables. There's variables in the denominator, not a polynomial. So this is actually something called a rational expression. A polynomial divided by a polynomial is not a polynomial, but it is a rational expression. Okay, so for some terminology here, we have a monomial. A monomial is going to be a polynomial with one term. So something like, for example, something like 4x cubed is a polynomial because it just has that one term, which is 4x cubed. A binomial, so look at the prefixes for all these words. Mono means 1, bi means 2, tri means 3. So a binomial is a polynomial with two terms. So for example, for this one, something like negative 2x to the fourth plus 3x. That's a binomial because it has two terms there. And lastly, for a trinomial, just like you expect, it is a polynomial with three terms. So something like x squared minus 5x plus 6, that is a trinomial because it has three terms there. Okay, so let's get into adding and subtracting. So for adding and subtracting polynomials, we technically already know how to do this. We do this by just combining like terms. So hopefully we remember what like terms are. Like terms are just terms that have the same variables raised to the same exact exponents. So let's do these examples. So let's perform the indicated operation and simplify. So the first one, we have negative 4x cubed plus 6x cubed. So we have to make sure they have like terms, which they do. They're both x cubed. Negative 4 plus 6 is 2, positive 2. So this is 2x cubed. So pretty simple, hopefully. Next one, we have 9x to the 6 minus 14x to the 6 plus x to the 6th. So they all are x to the 6th terms. So we have to do 9 minus 14, which is negative 5, plus 1, which is negative 4. So that's negative 4x to the 6th. Next one, we have y plus 2/3 y. So they're both y terms. So we actually have to get common denominators. So the first one we're going to rewrite as 3 over 3y. So 3 over 3y plus 2 over 3y. So that's so we can get those common denominators. So we're just adding fractions here because there was a 1 there. So 3 plus 2 is 5. So that's 5/3 y. Next one, make them get a little bit harder here. We have 8rs minus 13rs plus 9rs. So all of these terms are rs terms. So they can be combined. 8 minus 13 is negative 5. Negative 5 plus 9 is positive 4. So it's 4rs. Next one, negative 12m squared plus 5m plus 4m squared. So we have two m squared terms and an m term. We cannot combine the m term with the m squared terms. So it's going to be negative 12m squared plus 4m squared. Negative 12 plus 4 is negative 8. So negative 8m squared plus 5m. So we can't even do anything with that 5m. It's just going to stay put. Next one, we have 5u plus 12v. These are not like terms, so we can't even combine them. So we're just going to leave them just like this. 5u plus 12v, and that's all we can do. Well, we can't do anything. Okay, then we have 5x minus 2 minus 3x minus 8. So we have to distribute that negative 1 into both terms. So I'm going to drop the parentheses on the first binomial. And then it's going to become minus 3x plus 8. So the 8 becomes positive. So 5x minus 3x is 2x. Negative 2 plus 8 is plus 6. So 2x plus 6. Okay, and then for the next one, we have this polynomial with 4 terms plus another polynomial with 4 terms. So since they're both being added and we don't need to distribute anything, there's no numbers multiplying out front, so we can actually just drop those parentheses and ignore them. So I'm going to combine like terms now. So I'm going to combine the cube terms. So negative 9x cubed plus 13x cubed. Negative 9 plus 13 is 4. So 4x cubed. So I'm going to kind of cross these out as I go. 7x squared plus 2x squared. 7 plus 2 is 9. So that's plus 9x squared. Negative 5x minus 8x. Negative 5 minus 8 will get us to negative 13x. And then 3 minus 6, 3 plus negative 6 is negative 3. So we get 4x cubed plus 9x squared minus 13x minus 3. Next one here, we have 7x cubed minus 8x squared plus 9x minus 6. And now we're subtracting minus parentheses 2x cubed minus 6x squared minus 3x plus 9. So we have to distribute this negative to each term in that second polynomial. So I'm just going to rewrite this first one and drop the parentheses. And then essentially we're just going to negate everything in that second polynomial. So minus 2x cubed plus 6x squared plus 3x minus 9. So combining like terms here, 7x cubed minus 2x cubed, 7 minus 2 is 5. Next, the x squared terms, 8x squared plus 6x squared is negative 2x squared. 9x plus 3x is plus 12x. Negative 6 minus 9, negative 15, so minus 15. So we get 5x cubed minus 2x squared plus 12x minus 15. Okay, last one here before we graph. Subtract 6x cubed minus 4x squared plus 2 from 11x cubed plus 2x squared minus 8. So we have to be a little bit careful here. We're subtracting the first one from the second one. So when we're setting this up, we have to write the second one first. And then we need parentheses around the second one. The second one that we're writing. So it's going to be minus, and then in parentheses, 6x cubed minus 4x squared plus 2. So I'm going to drop the parentheses from the first one. I just kind of put them there to be organized, and then we need to distribute that negative. So dropping these parentheses. And then distributing the negative. So minus 6x cubed plus 4x squared minus 2. Combining like terms, x cubed, we have 11 minus 6, so that gives us 5x cubed. For the x squared, 2 plus 4 is 6, 6x squared. For the constant term, negative 8 minus 2 is negative 10. So 5x cubed plus 6x squared minus 10. Okay, that is adding and subtracting polynomials. Once again, it's just combining like terms. We should be good with that by now. So for the last 2 pages here, we're going to be graphing a little bit. So we're going to be graphing degree 2 polynomials. There's a better way to do this, but right now we're going to be doing this by plotting points. So far, we should have already graphed linear equations, which are degree 1 polynomials technically. And we're going to do it, we did that a couple different ways. We did it with slope intercept. We did it with x and y intercepts. I'm going to do this one by plotting points. And we're going to see that all of these degree 2 polynomials, so degree 2 meaning it's the highest exponent in the polynomial, it's exponent of 2. All of these polynomials that we graph are going to have this certain U shape, either a U facing up or a U facing down. They're called parabolas. So they have parabolic shapes, they're called. Okay, so let's do these examples. Let's graph y equals x squared by selecting integers for x. Negative 3 to positive 3. So it's going to be negative 3, negative 2, negative 1. Space these out a little more. 2, negative 1, 0, 1, 2, and 3. So we're going to plug these into the function to find their y coordinates. That'll give us an xy ordered pair. Plot those ordered pairs, connect them with a smooth curve. So y equals x squared here. So it's going to be negative 3 squared. We have to be very careful with the plus or minus signs. That gives us positive 9. Next, we plug in negative 2. Negative 2 squared is positive 4. Negative 1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. And 3 squared is 9. So notice how I dropped the parentheses from the number when it was getting squared, because we don't need them when they're positive numbers. But when they're negative, we do. Okay, so I'm just going to fill in these ordered pairs real quick. So we get all these points, and I'm going to plot them all. Negative 3 comma 9 is right up here. Negative 2 comma 4 right here. Negative 1, 1. 0, 0. 1, 1. 2, 4, and 3, 9. So we're going to connect these with a smooth curve. And it's going to look something like this, and just get in the habit of labeling your graphs. This is y equals x squared. So notice that I didn't just like connect the dots or anything. It's a smooth curve, so you try to kind of make it rounded. So the shape that you see here is a parabola. They're all going to look something kind of similar to this. This point right here, we can see that it's changing from decreasing to increasing. So scanning it left to right, you can see that the graph is falling to that point. Once it hits the origin, it starts rising. That turning point is called the vertex. It's called the vertex for a parabola. And it's important to know that it is not a sharp point, it is a rounded curve. Okay, so let's do maybe 2 more, I think, or maybe just 1 more. Let's do 1 more here. Let's graph y equals negative x squared plus 3 by using those same integers, negative 3 to 3. So negative 3, negative 2, negative 1, 0, 1, 2, and 3. Okay, so plugging these into this function here, this is where we have to be a little bit careful. So I'm going to kind of move down here a little bit. Do x equals negative 3. I'm going to rewrite the function y equals negative x squared plus 3. So when we're plugging in a negative 3, make sure you have your parentheses and make sure you have order of operations correct. You have to square the negative 3 first. So that negative in front, all the way in front, drops down. Negative 3 squared is positive 9. But that negative was already out front, so it has to stay there. So we get negative 9 plus 3, which is negative 6. Let's do it for negative 2. So y equals negative x squared plus 3. So we plug in a negative 2. And we get negative 2 squared is 4, but the positive 4, but the negative is still out front. So negative 4 plus 3, which is negative 1. So that's our y coordinate for that one. And then I'll do 1 more, and then I'll just pause the video and fill in the rest. And you guys can try those ones if you want to make sure you can do this correctly. So plugging in a negative 1 is negative 1, negative, let me erase that, negative 1 squared plus 3, which ends up being negative 1 plus 3, which is 2. Okay, so that's going to be 2. And I'll pause it real quick and just fill in the remaining ones. And here they all are filled in, and all the coordinates are filled in, the xy coordinates. So let's plot these points. So negative 3 comma negative 6 is right here. Negative 2 comma negative 1 is right here. Negative 1 comma 2, 0 comma 3, 1 comma 2, 2 negative 1, and 3 negative 6. So connecting these with a smooth curve, we get something like this. This is y equals negative x squared plus 3. So once again, we have this vertex, that turning point here at 0 comma 3. And also recognize that these are symmetric, right? If the last two that we did are actually symmetric over the y-axis, meaning they're mirror images of itself. It's a mirror image of itself over the y-axis. Okay, so this is another parabola, except it's opening downwards. Okay, so I believe that is it for section 4.4.